Okay, so I'm Suzanne, and I'm a hydrogeologist, so that means I'm a groundwater scientist. I'm looking at the water beneath our feet and trying to figure out the best ways to allocate it. I started my career actually working in the Andes of Chile, where I became over a few years the environmental manager for the 7th largest copper mine in the world. And in that role, I built my first decision support system to control all of the environmental data that was being fed to our main operation and control room at the field site. And I worked with Honeywell to do it. And in that process, we were taking on large streams of data for about 1995, 1996. And dealing with that was a real test and a challenge. And moreover, figuring out how to convey to the people at the operations of the mine site how to actually use that data to make sound daily operational management decisions was a continuous trial. And what I found was I was most touched and intrigued by the controls that I had to manage for the groundwater springs that were in a closed Andean basin that supported all of the wildlife and the environmental ecosystems that were important for the region. Cut to going back to graduate school to become a hydrogeologist, and I go back to the Andes with a multinational research team to visit the spring site and show them the success that this fabulous mitigation plan and automated telemetric data system I'd created was working, only to drive up after 2 hours on a dirt road in the Andes to a dead, dry, bone-dead spring. And I felt like I'd been punched in the gut. So I spend most of my time now trying to figure out how to combine, because in that moment I realized people, so take all of the models and the data and the information that we're working on and get it back to people in format so that they will actually use it. So that's why I do what I do. I work in geothermal systems, I work in groundwater allocation systems, and this is a website that is not ready for prime time, but I wanted to show you one of the data sets that we are getting ready to unveil. And then I'm actually going to, whoops. I'm actually not going to show you that. Okay, so quickly now going to my slides. So I actually spend a lot of time thinking about interfaces, and I'm at University of Texas now, where I'm working on Texas cases, but I'm also working on conflict-ridden cases around the globe, principally in water-scarce regions. These are where most of my field sites are, and you're finding things like farmers are taking science-based information and science-based water plans for the Murray-Darling Basin, and they're staging protests in Australia and burning the plan in the streets. In Chile, we've got indigenous communities are shutting down all of the energy development projects that the country needs to advance because of issues over water primarily. And then in Texas, of course, oh my goodness, I'm going faster. So I use technology as a boundary object. So I bring science and data and information into it. I figure out the delivery modalities, and then I also work in a social process. So on the left-hand side of this diagram is, I look at policy and patterns and information. This is actually the social process and looking at the social context piece of my research. In that, I'm actually doing some similar things with semantic frequency analysis. I just got like a rush from the 2-minute sign. But I look at frequency analysis, semantic, and categorizing text and concepts to actually build network diagrams. And I also do social process, conflict resolution process on that side of the diagram. I think that the data tilling services are going to be really important for that. On the right-hand side, that's actually where I started my research initially, and it's still underway, which is I build these decision support systems and use satellite imagery and all of the data streams you can imagine, going out into the field and streaming them up to a cyber infrastructure and using GIS. I also use narrative analysis and video of interactions with stakeholders, open-ended analysis. So video, that's one of the only places. Anyway, long story short, on 1 minute or less, DAP is going to be really important for the right-hand side of that, which is the more traditional scientific approach. And then the piece that's really important is the society piece at the bottom. I've done a lot of different things, but the thing that's been working and has been resulting in these incredible outcomes is I'm feeding the data onto large touch screens, and I'm going to just go quickly past all this other stuff. I'll come back to that, I promise. because what we developed with my students is an application that feeds out to a large touch screen. This is, you're just seeing a screen capture of someone actually is using this with their hands. That's a GIS data set that you can actually open up a lens and see through to deeper parts of the data set. A stakeholder can save their data and add their preference sets to weight what's important to them to generate a vulnerability map. And they can then save that under their user ID, feed it back into a repository, and you can now share it with your friends and buddies and the other stakeholders that you need to have a science-based dialogue with over a table, literally over a table, and have a discussion. We've taken this down to Chile, and the result is the indigenous communities that refuse to speak to the miners or the energy developers are actually now working collaboratively with them to develop a renewable energy plant that's going to be hopefully 10 megawatt was the original plan. We also have generated nonprofits and micro entrepreneurial ventures out of this. Or kind of the research is resulting in much larger things. So I'm out of time. It's fun.
Yeah.
Okay.
Yeah.